All right, problems number 8 and 9 from your Algebra Chapter 10 practice test right here. Problem number 8, we're given some information that the sum of two numbers that we don't know is 59. We do know that 3 times the first number plus 5 times the second number is 255. And we're going to write a system of two equations representing the information for the two unknown numbers from above. So I don't know what the two numbers are, so I'm going to call them, x and y. That's pretty exciting. So x and y, if we take those two numbers and add them together, we're going to get 59. Mystery number 1 plus mystery number 2 is 59. How do I know that? Because it says that the sum of the two numbers is 59. We also know that 3 times the first number plus 5 times the second number is 255. So here's our first number, and if I multiply that by 3 and add it to 5 times the second number, I'm going to get 255. So that other equation will look like this. 3 times the first number plus 5 times whatever the second number is will be equal to 255. And this right here is a system of equations that's representing the situation. The next part asks us to take that system that I've now written right here in part A and determine the value of each of the numbers, and we're going to show all our work, of course. So I have the system and I'm going to solve this system. I'm not going to use graphing because I don't want to. It's horrible. I don't like graphing at all, so I understand where people are coming from there. And it's not very useful either. It's kind of tedious, takes a lot of work, and we're not really guaranteed to get a correct answer. So I'm going to use elimination here, or addition. What I'm going to do is add these equations together so that one of the variables cancels out, and then I can solve for the other variable. But there's a problem with that, because if I add these two equations together as is, nothing's going away. X and 3x don't make 0. Those aren't going to cancel out. Y and 5y don't make 0. Those aren't going to cancel out either. So ideally what I want is I want this number right here to be a negative 3, or I want this number right here to be a negative 5 so that they cancel out. So what I'm going to do here is multiply the top equation by negative 3. What did I do to get this equation right here? I multiplied this equation by negative 3. Negative 3 times x is negative 3x. Negative 3 times y is negative 3y. And 59 times negative 3 is negative 177. Now, when I add these equations together, the x's will cancel out, because negative 3x plus 3x is 0. So reiterating again, how I got this system was I took this equation and I multiplied it by negative 3. So that's how this equation right here becomes this equation. And I do that because now when I add these equations together, I get 2y equals 78. Where does 2y equals 78 come from? Well, the negative 3x and 3x are gone, which is why there's nothing here. The 2y comes from negative 3y plus 5y. That's 2y. And the 78 comes from negative 177 plus 255 is 78. So if 2 times y equals 78, well, then it means that y has to be 39, because we can divide both sides by 2. So now that we know that y is 39, we can take this y, our second number, is 39. Take that number, plug it into the top equation, because x plus y, well, y is 39, has to equal 59. And if y is 39, therefore x has to be 20. So the solution to this system is when x is 20 and y is 39, as indicated by our ordered pair right here. Problem number 9, we have two persons, Nate and Amanda. They're swimming against each other in a race that is a total of 100 meters long. So they're racing 100 meters, and Nate is swimming at a rate of 4 meters per second, which we're going to call S, and Amanda swims at a rate of 5 meters per second, S, and Nate has a 15-meter head start. So we're going to let D be the distance remaining in meters after T seconds. So we have a little bit of unnecessary information here. The fact that this says S is completely unnecessary. And in fact, that's kind of worded a little confusing and in a way that is not conducive to the problem. So let's ignore the fact that this even says S, and we will make sure that on the test that nothing confusing like that is there. So we're just going to kind of look at this. So we're going to, D is the distance remaining after t seconds. So the seconds should all be t. So we're going to write a system of two equations representing the situation. Nate's equation for how far does he have left after t seconds? Well, here's the thing about Nate. Nate has a 15-meter head start. So in actuality, Nate isn't going 100 meters. Nate is going 85 meters. Why? Because he has a 15-meter head start. So Nate's only going 85 meters, and he's swimming at a rate of 4 meters per second. So that means Nate's equation is going to be, his total distance is going to be 85, because that's how far he's going, minus 4 times t seconds. So after every second, the 85 is going down 4 more meters. So Nate's equation, his total distance will be 85 minus 4 times t. If we want to know how many meters Nate has left after 10 seconds, we're going to do 4 times 10, and he will have gone 40 meters. Subtract that from 85, so he will have 45 meters left after 10 seconds. And that's what this equation right here represents. This tells us how much distance does Nate have after t seconds of swimming. So then Amanda's equation is going to be d minus 100 minus 5t. Why 100? Because Amanda's actually swimming 100 meters. Nate is not, because he has a 15-meter head start. He's going less distance. Amanda's going 100. But she's swimming at 5 meters per second, so every second she's gaining or losing 5 meters from that 100 that she is swimming. So here's Amanda's equation. So this is our system here. The D represents how many meters they have left, and then this is the 100 minus 5t, and the 85 minus 4t represents how many meters they have left after t seconds. So using our equations, when will Amanda catch up to Nate? Well, she'll be caught up to them when their distance is the same amount. So we will solve the equation then when Nate's equation is the same as Amanda's equation. So using algebra to solve, I'm going to add 5t to both sides to get rid of this minus 5t. So subtract 5t from the right-hand side, or add 5t to the right-hand side, add 5t to the right-hand side, and we get t. Because negative 4t plus 5t is t. Then we'll subtract 85 on both sides, and t is 15. So what does this mean? This means that after 15 seconds of swimming, Amanda will have caught up to Nate.